When we did exponential equations, we had two methods, common base, not common base. Logs work the same way. Either you have a log on both sides of the equation, which would be logs with common base, or you don't, which is not common base. So for example, 1 and 2 are two different methods, if you look at those questions on 345. 1 has a log on each side, which means we're going to be able to cancel those. 3 only has a log on one side, which means we're going to have to learn how to get rid of a single log because you don't have one to cancel with it on the other side. Okay? So, the difference between questions 1 and 2. First, we have to remember our condensing rules. Our condensing rules apply to this. So, for example, on question 1, the first thing that I see is this 2 out front. According to our log rules, where can I move that to? It can go back as the exponent of the x. So you need to fully condense each of these. If there is a log on both sides, you need to, just like the exponentials, get only one log on each side. When we just did the common base ones, we had to get only one common base for the exponential on each side. It works the same way for the logs. You can only have one log on each side. So now I have one log on each side. I have fully condensed this. These are both log base understood what? 10. Doesn't really matter as long as it's the same one, right? So in this case, if there's an understood base 10 on each side, because they are the same, I may cancel those logs and solve what is left. This is very similar to the common base method we did with the exponentials, where you cancel the common base, solve what's left. I am left with x squared equals 9. How do you get x by itself here?
Take a
Square root, and when we square root 9, what do we always put in front of it? Plus or minus. Here's the deal. You always put that in front of it, but what kind of numbers can you not take the log of? Negatives or what? What's the other one? 0. Okay? So even though you do put a plus or minus in front of it because of the square root, we only keep positive answers. So my final answer to this question, I eliminate the negative one because you cannot take logs of negatives, which just gives me x equals 3. Now, not all negative answers are going to be bad. It just depends on if you can plug them into the log and you are taking the log of a negative number. This one was straightforward. Because the x is by itself, you're just taking the log of negative 3 when you plug it in. But an example like this one in question 3, I can plug in negative numbers right there and still get the log of a positive number. So we're just going to be careful with those answers. Logs, it tends to be best to always kind of check your answers. Mentally plug them in. Okay? So let's give question 2 a try. We're going to talk about how to do it if there is not a common base, which is the rest of these really. Condensing rules, is there anything that I can condense back in question 2? Well, there's two options to start in question 2. What could I do with that 3? Put it back as the exponent, right? What is the easier way to deal with the 3? Divide it. Why did I not do that in question 1? Because you can't divide the 2 into the log of 9, not nicely. But in this case, if you can, go ahead and divide that 3 over here. Just get rid of it. So you could have handled that one of two ways. Either way would have been fine. Okay? Now, the last one, we had the same log on both sides so we could cancel it out. Here's what happens if you can't cancel it out like this one. You don't have a log on both sides. You therefore can't cancel your log base 3. Remember we said logs and exponentials are the opposite of each other? We're going to use an exponential to get rid of this. Or you can switch this into exponential. Exponential form, you would say, use your loop here to rewrite. If I rewrote this in exponential form, it would be 3 to the second power equals 4x minus 7. Is this something we are then able to solve?
Yes.
Yes, it is. What is 3 squared? 9, and from there it becomes a very easy solving process. All I have to do is add 7 to both sides and divide by 4. It's always good to check your answer. Here's what I mean by that. If I plug in 4 right here, is this parentheses going to be a positive number? 4 times 4 is 16, minus 7 gives me 9. Yes, that's totally fine. If that is not a positive number, no matter whether your answer is positive or negative, we have to get rid of that answer. So logs, you always need to check your answers. Exponentials, you do not. Any issues with question 2? The rest of these are going to be handled very similarly. We just have to go through the process of solving using our condensing rules. So that's why we spent that whole day talking about log rules and how to condense them. So for example, on question 3, before I do anything, I have 2 logs on the left. I can't keep 2 logs on the left. I've got to collapse it or condense it down to 1. What is the rule for plus signs? You can condense this to 1 log base 4 and do what with these pieces? Multiply them. Now, some of you will want to write those parentheses next to each other and then multiply it out. I'd save yourself some work and just FOIL it now. Okay? So I go ahead and FOIL that. X times 2 is 2x. X times x is negative x squared. 3 times 2 is 6. 3 times negative x is negative 3x. You can simplify that still. Or you can do that in the next step as you are turning this into exponential form. So how do I turn this into exponential form? I use my loop. Even though it's a big thing in the middle there, it doesn't matter. Exponential form would look like what? 4 to the 1 is equal to all of that, which I'm going to go ahead and simplify right there. Anytime we have a quadratic, how do we solve it typically? You factor it. I would probably move everything to the left because I don't like factoring negative x squareds. Take a minute, move everything to the left on your paper and factor. All right, hopefully we all got these answers originally. Let's discuss the checking answers process. It's checking those 2 circled spots there that you're taking the log of to make sure that you can still get the log of a positive number. So for example, 1. If I plug in 1 there, am I taking the log of a positive number? If I plug in 1 there, I'm taking the log of what? 4. Is that okay? Yes. If I plug in 1 here, am I taking the log of a positive number? Yes, I am. So 1 is fine. 1 worked for both of those. Now I check negative 2. If I plug in negative 2 in the first one, am I taking the log of a positive number? Yes, because negative 2 plus 3 gives me 1. 1 is okay. It doesn't matter that the answer itself is necessarily negative. When you plug it in and you see what you're taking the log of, that number has to be positive. So then I check the second one, being careful of minus and negative. 2 minus negative 2 is going to give me what? Positive 4. So even though that answer is negative, is it okay? Yes. You have to check what you're taking the log of. So we can keep both answers as long as you are taking the log of a positive number wherever you plug it in. Does that plug-in process make a little more sense? Okay. All right. Some of them are going to be more obvious, like question 4, because you're only taking the log of x there. Because of that, if you get a negative number, then that's automatically going to be negative. So some of them are easier than others with that. But let's do the same type of process on 4. 4 is actually almost exactly like 3. So go ahead at your tables right now and give 4 a try and see if you can do that one on your own. All right, so we get 9 and negative 3. Are both of those okay? No, the negative 3 does not work because when we plug it in here, it's taking the log of a negative, as well as over here. Really, it doesn't matter. Once one of them doesn't work, the negative or that answer is not going to work, period. So we just keep the negative 9 there. Issues, questions? All right, question 5. We need to collapse the logs in question 5. What would be the first thing that I do in question 5?
Step 1 would be move the 2.
Move the 2. Now, why can I not divide the 2 this time? Because this doesn't have a 2,
Oh, yeah, that's
right? So I'm going to bring the 2 back as the exponent here. Then what does a minus sign indicate? Divide. So I can collapse this to 1 log base 3 of the 2 parts divided. After after you get here, what is our second step, third step, whatever? You do the loop to rewrite this in exponential form so that we can solve it. So what's this going to be rewritten as?
3 to the fourth power equals x minus 4 squared over 9.
Yep. All right. Now, this one, for a non-calculator one, is a little bit high numbers, right? So here's a way to make this a little bit easier for yourself. What would you do next? Multiply by 9 to both sides. Do we know what 3 to the fourth is? 81. Do you really want to multiply 81 times 9?
Yes.
I mean, you can. But then what are you going to have to do next? Look ahead. Then you're going to have to square root that. Do you know how to square root the number that is 81 times 9?
Easy words. No kidding, I don't know.
It's a little bit funny. So here's a different way to think about this. 9 is the same as 3 to what power? 3 squared, right? If I multiply 3 squared times 3 to the fourth, what is it going to give me? 3 to the sixth. Do I have to know what 3 to the sixth is right now? No, probably not. Because when I square root here to solve, what is the square root of 3 to the sixth? 3 to the third. And anytime you square root, what do you put in front of it? Plus or minus. Do you know what 3 to the third is?
Yes.
Yes. And you didn't even have to figure out what 3 to the sixth was. Okay? Or if you don't like that, you may also square root before you multiply by the 9, because you can square root the 9 on bottom as well. So either way would work. So right now what I have is x minus 4 is equal to positive or negative 27, which means I'm going to get two answers. 27 plus 4, which gives me what? 31. Negative 27 plus 4?
Or negative 23.
Negative 23. Is negative 23 okay? No, because if I do negative 23 minus 4, it's going to be a negative number, and I can't take the log of that.
I have a question.
Yep.
So since that portion and that log is being squared,
Mhm.
that'd be fine, since it's positive.
That is always the question. If you have it written as squared, it would be fine, but if it's not written as squared, then it wouldn't be. So I tend to eliminate it just because the original was not squared,
Okay.
because the 2 was out front. Yep. It is a trick question. Did that square root process kind of make sense for bigger numbers? Yeah.
How do you get the square root of 3 to the 6?
I changed 9 to 3 squared, and then multiplied 3 squared times 3 to the fourth, which gave me 3 to the sixth by adding my exponents. And then the square root was just to get rid of the squared. I was just solving at that point. So I was saying, how do I get rid of squared? I square root both sides, so that's why I square rooted 3 to the sixth, which gave me 3 to the third going upwards. Let me go back a step here. Let's just say we didn't like that. Let's go back. All right. Were we good here? If we were good there, and you can get 3 to the fourth is 81, you could also solve this way. How do I get rid of that squared? You can square root it as long as you square root everything, right? What's the square root of 81? Plus or minus 9. Squaring or square rooting a squared just gives me x minus 4. And what's the square root of 9? 3. And then you could just solve from there. If that makes more sense to you, you can do that as well. I was just trying to avoid making it 3 to the sixth and then having to square root that without a calculator. Either way that I could. Either way works, though. Bigger numbers are kind of nasty for that. All right, let's finish this last one, number 6 on this page. I'm going to have to erase some of this stuff to get some room here. Do I have anything to condense in question 6? No. All right. I have nothing to condense. Everything is condensed for me. Therefore, what's my first step going to be? Writing this in exponential form. 1/2 to the negative third equals 4x to the 3/2. This one just requires use of exponent rules, which we always don't remember and tend to hate. First, let's deal with the 1/2 to the negative third power. What do negative exponents typically do? Make it into a fraction. If it's already a fraction, what does it do? Flips it, which makes it the same as 2 to the positive third. So 8. So once I get that figured out, this is easier to solve then. The other thing we need to remember is how to deal with this. How do I do a 3/2 power rather than a 3/2? It means the same thing as the square root of 4x raised to the third power. Now, why did I do that? Because I can actually solve this, right? How do you get rid of a cubed? Cube root both sides. Can I cube root 8 nicely? Yes, I can. What is the cube root of 8? 2. So I have the square root of 4x is equal to 2. How do I get rid of a square root? Square both sides. That gives me 4x is equal to 4, which means my final answer is 1. So that was just more a review of exponent rules to remember the negatives and the 3/2s. Now, the other side goes very, very quickly because these are all common base ones, like question 1. You'd collapse it to 1 log on each side, cancel stuff, and solve. So these tend to be easier because they don't have as many exponential things. So I'm going to get you started, but then let you try some of these on your own on the next page. The only rules for these, since notice if you look at some of these, like question 1. Oh, these are all a little bit different. All right, so question 1 is a good one for logs on both sides. So if there are logs on both sides, that just means I need to collapse everything that I can and then cancel the log that's the same on both sides. So where would I start in question 1? Bring the 2 back as what? Exponent of 3. So that would be my start. My second thing would be when there's 2 logs separated by a plus sign, I collapse that to 1 log where I do what? Multiply. 3 squared times 5 is what? 45. When you have the same log on both sides, what can you do? Cancel them out, which means what's my answer? 45. We don't spend a lot of time on the logs on both sides because as long as you can collapse them, you're pretty good. Okay. Take a minute, try question 2 on your own. We are not going to do 3 because that's another one of those not common base ones, and we've had a lot of practice with those. If you get 2, go ahead and try 4. When you get through this one, this is another good one that you don't just throw out the negative answer just because it's negative. When there's already absolute value bars in there, that means if you plug in your negative 13 here, you're going to get negative 13 plus 4 gives me negative 9, but the absolute value is going to make it what? Positive before you take the log. So is that okay? Yes. All right. Issues with that? All right. Last one's at the bottom here. All right. 5 and 6 are both exponential equations, not logs. So we've already done stuff with solving with this, but they're just a little bit different looking. Okay? So there's a couple of things to look at with this that you should kind of be able to recognize. Anyone see what 5 kind of looks like?
Kind of like quadratic.
It's kind of like a quadratic. How do we recognize that?
I don't really know.
But it's really good that you said that because it is actually. And that's what I wanted you to see. Notice, a quadratic is generally in this form. Do we see how that kind of looks similar? Yeah, there's, the first term has a squared. The second term has just a basic x. The third term's just a number. It works exactly the same way as normal factoring. Normally, if I factored something like this, it would be x and x, right? Well, this time I don't have an x and an x. So what do you think you could put first in each parentheses? E to the x. If I multiply e to the x and e to the x, it gives me e to the 2x. See how that works for that one? Now, this isn't any harder than normal factoring. The rest of this, after you figure that basic form out, all you have to do is the same thing we normally do. What multiples of 4 will give me negative 5 in the middle? Negative 4 and negative 1. Now, you will have to solve after this. What do you have to do now to get, or what do you do with your factors once they're factored?
You set them equal to 0.
Set them equal to 0. So you can do that very quickly. If you set both of them equal to 0, that gives me e to the x equals 4 and e to the x equals 1. You're still trying to solve for x. So in each one of those, what do you still have to get rid of? The base e. What's the opposite of base e? ln. If I do the ln here, I also do the ln here on both of them. Here it's going to cancel, which is just going to give me equals ln 4. Here, that's going to give me x equals ln 1. Anyone remember what the log base anything of 1 is? 0. So you do get one nice answer that's just 0. ln of 1 is 0. Log base 10 of 1 is 0. Log base 5 of 1 is 0. Log base anything of 1 is always 0. You can also handle 6 a little bit like that. Okay? It's not set up like a quadratic, right? Because it's only got 2 terms. But we kind of did one like similar to this when we did the not common base. What do you notice is common to both terms in question 6? The e to the x is common to both of them. If something is common to both terms, what can you do with it? Factor it out. These are just different ways of thinking about them that I figured we'd go over rather than throw things at you. If you take out an e to the x, what's left in the first term? X squared. And what's left in the second term? Minus 3. And once you've factored, how do you solve? Set them equal to 0. So what's the first thing that I'm going to set equal to 0? Okay, I set the x squared minus 3 equal to 0. What else am I going to set equal to 0? E to the x equals 0. Now, let's just solve one at a time. How do I solve the x squared minus 3? Okay, so I get 2 answers from that. What are they? Plus or minus root 3. Question, do I have to check negative answers on this problem? No, because it doesn't have what in it? A log. How do I solve this one? How do I get rid of the base e? ln. Can I take the ln of 0? No. So what does this give me? Nothing. Now, I don't write no solution because I already had 2 solutions, right? But that one doesn't give me a solution, and that's okay. All right, so those were a little bit weirder questions, I know. But homework time. Okay, we've got 25 minutes in class to do homework. Real quickly. Starting on page 351. Homework's going to be on 351. We're going to go ahead and do question 1 through 11. And then we're going to do page 354. I'm going to pick questions on this one. 2, 3. Let's do 10 through 12. I think that's good.